just as we wait for everyone to join us, I'll probably say this again, but the transplant idea, a head and a body from two different people.
Yeah.
Personally, I think this is ridiculous.
Yeah.
Personally, I think it's I don't expect it to ever happen, and I actually hope that it never happens. My motivation in presenting it as a topic of discussion is to elicit ideas and opinions, not because this is realistic. So for those of you that find this terrifying, I'm with you. I'm really with you. Let me say that in general the conversation has been extremely, on the other hand, the conversation about the idea has been extremely interesting, and it has actually moved my own opinion. I am a incredibly cerebral person. I value my thoughts probably a little bit too much, and so talking about transplanting a head which has an intact forebrain and which, in my worldview, has everything that one could possibly want onto a different body, really challenges my own ideas about body. And I've come to realize that a little underestimating how important the body is and how important the body is to identity. So the brain is not in a vat. It is not in isolation. We are not talking, as the French say, encéphalé isolé. And using it with the body is absolutely critical. So I've moved in my own view, and that was the whole intention of this exercise.
Well, it really worked. It worked for me, at least. Am I in broadcast now?
You're
Emily?
in broadcast now. Go for it.
Okay. Because it was really inspiring. It got me thinking, and I thought, well, my hormones do sort of interact with my brain as well, and so does all of myself. So it really inspired some good thought in me, and I thank you very much for posting it on the forum. And I really appreciated the views of all the students, because that's really getting it all together and getting the input from all the different people. So if that was your intention, well, you totally succeeded, I think, and it's wonderful.
Yeah, great. I agree with you, Ellen, that hormones do influence the brain. I remember at one point I had a hormonal issue, and I was so irritated that I was unable to conquer my hormones with my brain's intentions. So I don't really like any bodily system as much as I like the brain, and I would love the brain to be the superior and the dominant and the only. And the reality is that that's not true.
No, and as someone who has had a lot of experience of hormone therapy, I do tend to think that, you know, the whole like hormone to mood thing is a little over exaggerated, but it does certainly play a role. And when you have a huge shift in hormones, it definitely screws with your brain a little. Like that definitely ties into, you know, your concept of self. Even just your comfort levels with your current hormone levels.
So do we know to what extent hormones can be manipulated? Okay, so if you switch brains, okay, you switch brains, you've still got a functioning heart, a functioning lungs, et al. So why don't we know enough about hormones to shift them around to make you feel okay?
Well, I do know that people with thyroid problems, they can sort of with hyperthyroidism, so you have too many thyroid hormones, and then you get
Right.
all agitated and worked up. And then what they do then is they can treat it with medicine that sort of puts out your own thyroid gland, and they give you the thyroid hormone to a certain
Right. That's
level.
what. Right.
Okay for some people, so that hormone could be done, but the whole hormone system is an intricate balance of a lot of hormones from a lot of places, and you can't really sort of the how did you call it, the pituitary gland, that's called the hypophyse in Dutch, that's why it's so difficult for me. That's really
Oh.
the director of the whole hormonal orchestra, and that is, well, that fine-tuning is not something that can be done artificially, I think.
I think that's right. So there's a lot of rhythmicity to hormone release that is natural and endogenous, and that's very difficult to imitate with exogenous hormones. But the thing that, but you still can. You can replace hormones. You can add or antagonize hormones. What you can't do is change right now you can't change the receptors in your brain to those hormones, and so you're still going to interpret those hormones within your brain, and that's something that maybe was less appreciated when I first started graduate school, but now we know that that certainly there are hormone receptors on neurons in a lot of places within the brain.
So, I mean, that means that the whatever everybody's body puts out a slightly different version of the hormone, so the receptors in your brain might not be able to accept them, receive them, be stimulated by them, or receptive to them.
Well,
Is that
I
what
think
you're saying?
it's more that the brain receptors are variable,
Right.
and they're probably variable between men and women. So they're variable between individuals, they're variable between sex, they're variable across age, they're variable for all manner of reasons. And so even if you could completely imitate one individual's hormone status in another individual, the experience of that hormone status would be very different because you have two different brains with two different complements of hormone receptors and hookups. Does that make sense, Aaron?
Yeah. But okay, but if my kidneys and yours are compatible, let's say for a transplant, would that mean that my heart and yours would be compatible as well? And if so,
if
I'm
so,
saying, if so, then why wouldn't you just find a compatible body? Find somebody whose heart would work with you. Is compatibility a general phenomenon? Could you view it as a general phenomenon?
but you're talking immune compatibility. That means you're talking about, are you going to reject or accept a transplant?
Yeah. Well, okay.
And that's a
more.
little bit different.
Got it.
So, are you going to accept or reject a transplant with
Right.
the aid of some immunosuppressants? That's going to be common to whatever organ you decide to transplant. But are you going to be comfortable as a person, as a self, with somebody else's body? And that's something that I don't think I would be comfortable with. And I think I think actually, as the students brought up, the face transplants is a part of the way towards this. So the fact that
you want to repeat the last couple sentences? The audio just cut out a little bit.
Okay, so immune acceptance is one thing. You can either reject or accept a transplant because you're a good match for another individual.
Right.
But accepting or rejecting it for a more neurobiological or psychological reason is a different matter altogether.
Of
And
course.
could you live with your head on somebody else's body? That, I think, is going to be a challenge. And I think as the students brought up, a good, the best approximation to that we have to date are these face transplants.
See, I think
And
this
the
is
face
cool.
transplants, what's that?
I think this is cool because we do have some approximations out there. Like a lot of the students brought up not only face transplants, but we have people, amputees, people with robotic limbs, even trans people experiencing bodily dysphoria. We do have a lot of examples. It is science fiction in a way, but we do have some representation out there that we can take a look at and evaluate.
Right. Right.
Okay, we're at 21 viewers, so if we want to start
Can we
answering
put them
some
up on the
questions.
screen, Emily? Can we
I
put the
can
pictures
put.
up?
I believe I can invite some people if they're in the Google profile event itself.
Okay. I would
There's
love to
very
hear.
limited
So
people in there. Okay.
let me go through a couple of the questions that we got. One was on this issue of motor neurons. Okay, so I admittedly an evangelist of one on this topic. Actually, I'll say two. So my view is that a motor neuron, motoneuron, M-O-T-O-N neuron, all one word, is the neuron that sits in the central nervous system and sends an axon out to a skeletal motor, to a skeletal muscle. That is a very special neuron. It contains acetylcholine. It has a certain structure. It gets a large number of very specific inputs. It has its own complement of ion channels and receptors, and it is susceptible to its own problems, such as polio, such as it carries tetanus toxin. It has very particular properties, and those properties are not shared by any other neuronal type. They are not shared by, for example, neurons in upper motor control centers. So what's the upper motor control center that we all think the most about? It is the motor cortex. And so what happened, and this happened in the early 1900s, was that people talked about motor neurons, and then they talked about upper motor control center neurons. And somewhere along the line, people got lazy, and they stopped including the center part. So instead of saying upper motor control center neurons, admittedly a mouthful, they started to say upper motor neurons. And that gave the world this false and very misleading impression that the neurons in the motor cortex are in some approximation very close to motor neurons. Not true. Let's take the biggest difference. If a motor neuron fires a spike in a healthy individual, there will be a twitch in a muscle fiber, in a muscle. All of the muscle fibers innervated by that motor neuron will twitch. If a neuron in the motor cortex fires, nothing happens. Nothing happens. It does not have that influence that the motor neuron has. And so that is why I try and really emphasize the difference between a motor neuron and an upper motor control center neuron, including a neuron in the motor cortex. Sadly, I'm fighting a losing battle. And certainly in the clinical literature, what you will see is the terms upper and lower motor neuron. I hate these terms. I won't use them. But yes, you will encounter them, you will see them, and I'm probably not going to change that. It's not going to be one of my legacies, shall we say. But that's the whole thing about the upper motor neurons.
So this answers another question on the forums. In the discussion forums, students were asking, what would I find in a neuroscience paper, in an actual paper published in a journal? So they might frequently find upper and lower motor neuron terminology then?
Oh, I see. So in a clinical paper, it's always in a clinical paper, a clinical textbook, a clinical anything. It's always going to be upper and lower motor neurons.
Okay.
That's become the standard.
Yeah,
Not in a basic science research paper.
No, but a lot of our students are also come from a medical background, so it makes it hard for them to understand what you mean by the motor neuron. I had trouble understanding it and translating it to my previous knowledge, to what I already knew. So that's what inspired a lot of questions on the forum, I think.
I totally understand that it's confusing, and if I were a bigger person, I would just let it go, and I'd adopt the general terminology. And I'm not that person. This is just one thing I have a thing about. But I do understand the terms, and I do understand the pressure to adopt those terms. I simply strongly disagree with that. So I won't use it, but I do understand that it's used. It would be, there are a lot of misnomers in the literature, in terminology, and another one is the optic nerve. But I don't feel on any crusade to change that. The optic nerve is not a nerve; it's a part of the central nervous system, and nerves are peripheral entities. It's not a cranial nerve.
Now you would have to say the optic disc.
It should be the optic tract, but the optic tract is already taken by the stretch of axons that goes between the optic chiasm and the thalamus. So you can't say that, just for historical reasons, and I accept that. For some reason, I don't accept the motor neuron thing. So, but it's okay. It's okay.
Yeah, there's also something like the basal ganglia. They shouldn't be called the basal ganglia. They should be called the basal nerve.
Well, actually, the reason that the basal ganglia is called the basal ganglia is because during development, the telencephalon has two parts. It has a dorsal telencephalon, which is a very thin layer of cells, and that becomes the cerebral cortex. And then at the ventral telencephalon has two bulges. Let me see if I can get this on screen. A bulge, I can't get that. Anyway, it has two bulges. And each of those bulges is called a ganglionic eminence. And that is the root of the word basal ganglia. Basal for ventral, and ganglia for the ganglionic eminences. Now, truthfully, the basal ganglia are only the striatum and the pallidum. The striatum, which is in us the caudate and the putamen, and the pallidum, which is the globus pallidus. It does not refer to these other parts that we have incorporated into the term, the modern term, basal ganglia, and I think rightfully so, because the striatum and pallidum in the human work with these other partners, the substantia nigra, both parts, and the subthalamus. So that is now what we term the basal ganglia. But you're right, it doesn't come from there are inaccuracies in that terminology.
Okay, fantastic.
Are there more questions, Emily?
We have plenty more questions. Jaleed's, like you answered the first half of Jaleed's question, he still had another question.
Let me answer the last part of Jaleed's question, which is that somebody, I actually saw this on Twitter, maybe it was Jaleed that sent it originally, but there is a report out of Harvard, out of Sabatini's lab, that there is a connection from the basal ganglia, and all I could see was the report, the press release that came out of Harvard. I didn't see the original paper because it's behind a paywall, which I can get through because of my affiliation to the university, but it's annoying as hell, and unfortunately it's not open access. So I haven't read the original paper. But what it purports to say, and I think what it's saying, is that there's a connection from the pallidum directly to cortex, to prefrontal cortex, that does not include a synapse in the thalamus. Okay, so from basal ganglia to prefrontal cortex without an intervening synapse in the thalamus. That would be a new, as yet undiscovered pathway from a region of the brain which has been extraordinarily well studied. I am, at this point, waiting to see the evidence. I emailed a friend of mine who's an expert in the basal ganglia, and he was a little skeptical, also wanted to see the evidence. I will say that from the press release, what it appears is there are no details given. The only detail given is that this was a study of optogenetics, and I would worry if we would establish such an revolutionary connection on the basis of this relatively new technology. We don't know all the pitfalls. We don't know all the potential artifacts that optogenetics can produce. So I think the jury's out, but I will look at this. My friend will look at it. We'll discuss it, and I'll get back to you with my opinion. And I always reserve the right to be wrong. And I actually I don't want all of you to share my opinion. That's never been my desire at all. All I want is for you all to be interested and to form your own opinions. That would make that would make me so happy. So but my opinion is, I'm not sure. I'm a little skeptical, and I'm not sure. And I'm annoyed that it's not open access. Okay.
Okay, so I'd just like to have a shout out. If you want to ask a question in the Hangout and broadcast yourself, your video and audio, you need to post your Gmail address or get into the G+ profile on our event page, or you can send a tweet to myself or the professor. We have to invite you into the broadcast.
Don't send it to me, because I don't see it.
I'm monitoring your Twitter, Peggy.
Oh, okay.
So that's okay. You can send it to either of us, but you don't join automatically. There's some people complaining that they can't participate because the room is full. The room is not full. There's so many students watching. We have to do it on an invite basis. So if you want in to ask a question, you can come in temporarily, ask your question, and be broadcasted there.
And I actually want you guys to do that because I want to see your faces. I want to see you talking.
We want to see the neuromookers around the world.
I do. I really, really do. Okay. Another question, Emily?
Another question, sure. Let's see what we have.
I can tell you, while Emily looks at it.
If you have a list, go for it.
I'll tell you something that happened this morning, that I saw this morning, which I think is really, really interesting. So one of the curiosities in my former life, right now I study empathy in rats, empathy and helping behavior in rats, and I love doing that. But I spent 20-some years studying studying pain, studying nociceptive processing, pain pathways, pain modulation. And so I have this enduring interest in that field. And I saw this morning that somebody had looked into why does a very loud sound hurt your ear. Now, why is that a question? Well, because the cochlea is actually not innervated by somatosensory afferents. So there are no touch or pain or temperature sensory neurons that are that innervate the cochlea. So how do we respond to these really loud noises? And so what this study, and I have not looked at it, again, behind a paywall, not open access, annoying, purports to show in the abstract is that the spiral ganglion cells, 95% of them innervate the inner hair cells. Remember that you don't remember this because you haven't had it yet, but you will have this. The inner hair cells are the hair cells in the cochlea that send their information to the brain and allow us to hear stuff. And they're very well myelinated, and they're very well described, and blah, blah, blah. There are 5% of these sensory neurons that form the vestibular nerve that don't innervate inner hair cells. They innervate outer hair cells. Now, outer hair cells don't signal information that we use for hearing perception. They do other things that we'll look at you'll look at when you get to the hearing part. Interestingly, it's those fibers, and they are unmyelinated, as are most nociceptors. Nociceptors are afferents that lead to a perception of pain. So these are this 5% of the sensory neurons in the ear innervate the outer hair cells and signal pain. They're excited by extremely high decibel sounds, even in mice that have the 95% of the spiral ganglion cells that innervate the inner hair cells have been ablated, have been genetically ablated. So all they have is this 5%, and it still signals a noxious event. So that's a pretty, I always wondered about that. I always wondered, why is a loud sound perceived as painful? And now it looks like we have an answer.
Fantastic. Okay, we have some questions from Google Plus's Q&A now. So basically,
Okay.
we're just going to go through the list, selecting them one by one.
Good.
Okay, so the current question is, hormonal problems aside, how could the brain fuse with another spinal cord? And if it is an entire CNS transplant, then how would each of those billions of connections throughout the body be fully connected?
Exactly. Today, we can't do that. We can't. If we could connect axons across a cut in the central nervous system, then spinal cord injury would not be a problem. Spinal cord injury is a big problem because the central nervous system is not a hospitable place to axons that are trying to repair, to reconnect. They don't. They just don't reconnect. And so this gentleman that thinks he can do this in 2 years has the idea that he's going to cool everything down and give it molecules that are essentially supportive, facilitative of regrowing and reconnecting axons. Will they make the right connections? Who the heck knows? I have my serious doubt. I mean, I don't think they'll make the connections. If they were making the connections, then we'd be solving spinal cord injuries, and we're not. This problem of the inhospitable central nervous system has been around for a long, long time, and certainly we understand a lot more about it, but we haven't conquered it, and I have my doubts as to whether we'll conquer it in 2 years.
Okay, on a related question, someone is asking, has there been previous developments on neuron cell fusion with polyethylene glycol? What could that mean for smaller procedures, from smaller limb transplants to treating injuries?
So, yeah, I don't know this literature that well, but polyethylene glycol is a good way to to try and promote these reconnections. But again, it just is not panned out in any kind of a big way. And the best thing, I thought the most exciting situation with a spinal cord injury was the time there was a football player who had a very bad spinal cord injury, but within minutes, I believe, he was put on ice. And what they basically appeared to have done was to prevent all of the freak out within the spinal cord, so that all these molecules that are going to oppose repair and regeneration were not allowed to get going. And he made a complete recovery. It was a fabulous story. But I'm fairly, my personal opinion is that was due to this cryoprotection. Very quick and very strong cryoprotection. Emily?
Okay, fantastic. I'm just going through more and more questions. One question we have on the discussion forums a lot is, at the moment of connection, so when we connect the medulla to the spinal cord, what is going to happen with proprioception and homeostasis? Will the brain be able to even, what might be some consequences of collaboration between those systems?
Yeah. It's a great
open question.
What? What'd you say, Emily?
This is the big open question. We don't really know, but
yeah, I really don't know. My suspicion is that so let's put it this way. When you're young, you're a baby, you have a sensitive period. People used to call it a critical period. And to a certain extent, in some systems, it is a critical period, but it is definitely a sensitive period. But as that sensitive period decreases, and as you become an adult, it's not as though you have zero ability to adapt and change in your brain. You actually have to, you actually have a finite level of ability to change, a finite level of plasticity available to you, but not a lot. But even with that little bit of adult plasticity that remains available, people do change as their bodies change. And so I would suspect that with some time, you could get a hookup that was more geared towards the new limb or body, and less towards what was expected, what was originally connected to the cortex. But I don't know.
That one is yet to be discovered. Okay, we have a question more just regarding general course material from Jason. Selecting question. Just so I understand, all neurons only have one axon terminal. Can neurons utilize more than one neurotransmitter, or only certain related to various neurotransmitters? This question was brought up on the forums before. We do have a thread on it in the forums, but if Peggy would like to bring her own answer to it right now, that would be fantastic.
So neurons have one axon, but they do have many terminals. Most neurons have many terminals. Okay. So thousands in many cases. There are a few neurons which only have one terminal. Photoreceptors, for instance, have a terminal. But your old average central neuron will have many terminals. I'll post a picture of one of my cells from way back when that I filled, and I mean, we're talking thousands of little beaded terminals that go all over the place. So there are a lot of So one cell will talk to lots of other cells. And even for a motor neuron that goes to talk to a skeletal muscle, it talks to more than one muscle fiber. Every muscle fiber only gets one input from a motor neuron, but every motor neuron talks to more than one muscle fiber. So you can have lots of synaptic terminals. That's the first thing. The second thing is, do they use more than one neurotransmitter? All the time. It is very rare for a neuron to only use one neurotransmitter right now. So typically there is at least one neurotransmitter that is of the low molecular weight type. So these are glutamate, GABA. Usually glutamate, GABA, or glycine is in almost every neuron. And then there also might be a monoamine, such as serotonin or dopamine. And then there also might be a neuropeptide or two or three, such as TRH or substance P or galanin or whatever. So there are lots of different neurotransmitters in many, many neurons. It's more the rule than not that a neuron has multiple neurotransmitters. Now, what's interesting is that these neurotransmitters are packed into different types of vesicles, and they may be released with different types of firing patterns. So one firing pattern releases vesicles that contain glutamate, whereas a different firing pattern may release vesicles that contain a neuropeptide or, say, serotonin. Okay, so there's a lot of subtlety there. There's a lot of differences in the way that a neuron can talk, even though it's releasing lots of different neurotransmitters, and even though it has all of these tens of thousands of or thousands of synaptic terminals.
Okay, we have a question from Judy when it loads. Okay. Have there been any ethical concerns or debates that have happened involving this particular head transplant? If yes, what would those be? So since there hasn't actually been a head transplant yet, has there been anything, more in the scientific community itself, and not just in, fringe discussions? Has there been any more official debate on this?
I don't think there's much debate on this because I don't think the scientific community is paying this much mind. I think this is not a realistic possibility. And I actually hope it's not a realistic possibility. I think it's I mean, again, this is my personal view, but I believe this is an entertaining and valuable philosophical discussion to have. I do not believe it's a valuable way to spend time and money. That's my personal view. And the ethics of it are I don't think we could ever touch on all the ethical concerns involved.
Okay. Jalid, you had a couple questions. Peggy did answer them. I think you may have missed them in the broadcast, but this is recorded. It'll be available to watch on YouTube later. She had a long, awesome reply to it, so you can watch this after the broadcast. It was a long reply, so.
No, I think I went through the ones I have, yeah.
Okay, one question we have is various gut microbiome connections, and Peggy, I believe you went to a conference where you did watch a talk on something a little related to this.
Yeah, I went to a symposium on this, and I was kind of blown away. The microbiome has taken the GI field by storm, so to speak, and now it's making its way into neurobiology. Now, I remember for a number of years it's been clear, and I remember Rita Valentino really has talked about this before anyone else was talking about it, which is that there is a incredible, what we call comorbidity of neuropsychiatric diseases such as depression and GI issues such as irritable bowel, and others. I don't want to pick out just those two, but there is a very strong coincidence of people suffering from both a neurological disease that is in the realm of psychiatry, in the realm of mental health, and also suffering from issues in the GI tract. And she noted that, and certainly the nervous system influences the function of the enteric nervous system. I'm sorry, the central nervous system influences the function of the enteric nervous system, which is contained within the digestive tract. And so using that, we can, our emotions, our stress, our excitement, our fear, our nervousness, all of that can get played out and change how much peristalsis there is and how much secretion there is. So how watery or how not watery, how firm stool is. And so we know that there's this interplay between the central nervous system and the gut. Once the microbiome became obvious, the extent to not obvious became more studied, more popularly appreciated. People have taken that and looked at its role in a variety of central neurological functions, such as there's an idea out there that that the biome can influence neurodegenerative diseases such as Alzheimer's disease. Now, when I talked about this with one of my colleagues who's an expert on Alzheimer's, he did not put too much stock into it, but there are certainly people who think that there is a pathogenic component that comes in through the gut that influences, at least in some cases, the development of Alzheimer's. And then at this conference, people were talking about the role of the microbiome in causing an autistic-like condition in animals. So there's a lot of caveats there. First of all, how well does the animal model autism? Okay, so maybe, maybe not. And then the idea that you can rescue an autistic-like mouse by changing the microbiome, that's the extreme of the claim. And with these things, all I can say is I don't know, and I think the jury is out. I think it's very interesting that people are looking at this, but I just don't know, and I don't think any of us really do know. And that's what but I think it's really interesting, and I follow it and I watch it. I'm interested, but I'm not convinced yet.
So that does bring about the hypothetical situation where a head transplant is completed, and the body with someone with depression or some kind of mental illness, and then the person who's receiving that transplant then suddenly gets depression. I know there was a case with the various fecal transplants lately. The fecal transplants have become a new treatment for various, I believe it's C. difficile, I'm not pronouncing that right. But there was a case that got a lot of media attention where a mother received a fecal transplant from her daughter, and she ended up gaining massive amounts of weight despite being at a healthy, normal weight for the vast majority of her life. So it would be interesting to see if head transplants would have similar effects on mental illness. But like as you said, we're not entirely, the jury is still out on the various connections between that.
Well, I think that we're going to see fecal transplants, which
definitely.
I mean, they're happening, and they're going to continue to happen, and so we'll find out from that alone. I really don't think we're ever going to see a body transplant onto a head. So I don't think we have to worry about that. But we will see the effect of these fecal transplants.
Great. Okay. We have a question from the G+. In the discussion forum, I've remarked on the brain's plasticity and its ability to integrate the radical physical change of having a new body. What do you think about plasticity as it relates to head transplants?
Well, yeah, I think that we have adult plasticity, and in the theoretical concept of transplanting a body, a dead person's body onto a live person's head, there's going to have to be a lot of plasticity if that partnership, that new partnership, is going to work. You're going to have to refigure out, oh, when these neurons fire to this degree, I move that much. Well, if I have Aaron's arm instead of my arm, I may move that much instead of this much. He's got stronger muscles, or he's got a longer arm, or whatever. So you have got to change. The brain has to rehook up, and that is going to be a challenging theoretical challenge. Yeah, I lost your video there, Emily. Emily, I lost your video.
Okay, we have another. Are we good now?
Yep.
Okay. We have a question. Do you think it is possible to maintain a live head without a body at all? So this is the whole brain in a vat thing, basically.
Yeah, I actually do. It's the old idea of encephalae isolae, and yeah, I think that's actually theoretically completely possible.
Cool.
And I'm not signing up. I'm intentionally not signing up. No interest.
Okay, I think we've covered the broad scope of the discussion forums.
Great.
And okay, so that takes care of that question. All the other questions in the Q&A right now we have answered in previous parts of the broadcast. So you can watch this broadcast and skim through it after we've recorded. It'll be recorded and posted on YouTube. Should be, according to Google, that happens quite quickly. So do we have any final comments, anything?
Yes, let me just say this is fun. I really love teaching in Coursera. I love teaching the NeuroMOOC because I love hearing all of your different ideas. So tell us whether this Google Hangout thing works for you. If you'd like a different format. Last time I didn't do Google formats. We just did interactions through the discussion forum. And I wanted a little bit more face-to-face. I didn't get enough of your faces. So
yeah, so I think next week we're going to try to coordinate with the Google Plus event page a little more, get students' faces in here, and have more official Q&A set up. So maybe watch out in the next couple of weeks, and if we can maybe have the discussion forum topic posted well in advance, and a specific place to ask specific questions. Because it would be nice to go through our whole class thread on this, but unfortunately it's at almost 300 posts now, and it's a lot of broad topic. There's not a lot of specific questions that Peggy can go on and answer.
Well, and also the discussion topics actually, truth be told, my intention is not to answer anything. I only want to
enliven the discussion.
I want you all to think about this stuff, and I don't want you to think like me. I don't want you not to think like me. I want you just to form your own opinions. I want you to be informed so that you can form your own opinions. All I care about, really all I care about, is that you think about neurobiology. Okay? That's all I want from you. And so, great. And let us know if there are other ideas that you have for how we can interact through whatever medium. Okay. Thanks, everybody. It was fun talking with you. See you next week.